Hello, hello guys, welcome to my new YouTube video. Today we are going to start for the new tutorial that is for the MongoDB. In this tutorial we are going to learn from the basics to the more advanced topics of the MongoDB. We will cover everything from the basic to advanced like a concept like the aggregation, lookups and the various different queries like GeoNear, GeoWithin, GeoWithin. Okay, so let's continue on the same. In this video, in this first video we are going to learn what is NoSQL and why the NoSQL came into the picture and why it is becoming so famous. Okay, so let's try to understand from the history of the relational database. Okay, so at the old era that in the 1917 year, about 1970, the data is stored into the file storage. Okay, but at that time the cost of the storage is very high. So the developer or engineers are tried to reduce the storing the duplicate data. So it will use the efficiently use the storage available storage. So that time the concept structured data came into picture, that is the relational data. So in the relational data we are storing the data and trying to reduce the duplication storage of the duplicate data. Okay, so for that we are following some structure or some relations to achieve that. So let's consider by how to do it by using the RDMMS, that is using the SQL. Let's try to understand by using the example. Suppose that we have the tables which contain the data about the student. Okay, so first column is the ID, second is the name, and third is the school where the student is learning. Okay, the first ID, the name of the student is ABC. He is learning in the school A. Okay, for the second, the name of the student is XYZ and he is learning in the school A also. So as you can see, for these records we are simply trying to store the duplicate data, that is the name of the school again and again. So instead of that we can create the another table like school, and in that we can store the data for the ID, name of the school and other details of the school like address or any other thing. Instead of the adding the all the fields of the schools also in the student table like the address of the school, so it will, if the address of the school is the Pune, then for the both the records we are saving the same data again and again, that is the school name, address of the school, and if suppose there are the multiple fields for the school, then those fields also. So we are s- trying to store the duplicate data. For that we can create the simple table. In that table we can create like first ID, name of the school A, and the address of the school Pune. And instead of the using this, we can simply give the ID to the both the records. So at that time we are storing the details of the school in the one record only, and simply giving the ID of that record to the student. So it will reduce the storage of the duplicate data. So that's why the relational database came into picture to reduce the duplication of the data. Okay, as you can see there are the two tables, that is student and the school. In the student table there are the three records for the John, Pradeep and Amol, and for the also in the school table there are three records like ABC. These are the school names and address of that school, that is Pune, Mumbai and Delhi. Okay, for the John and Pradeep the school will be A, and for the Amol the school will be B from the Mumbai. Okay, for the as in previous section we learned about how the data duplication, data redundancy is uh, removed from the when we are creating the different table. Instead of the storing the same data in the same table, we separated that data in the another table and simply give the id of that record to the first table. Okay, so instead of the storing the same record again, we are storing it in the another table. Okay, at the time when we are trying to fetch the all the details about the John, including is the personal details and the school, at that time we have to create the join between these two tables. Okay, so we have to fetch the data of the John, and also from the school ID we have to fetch the data from the his school table. Okay, so for now, yeah, there are the two tables, but when we are considering the more complex applications, at that time we have to get the data for the single record from the multiple tables. At that time we have to create the location joins for the multiple tables. At that time it reduces the speed, the performance of that query. So as the we are trying to achieve the removing the data redundancy, at the same time in the querying the data using the joins, we are decreasing, also decreasing the performance of the our application. So when the performance decreases, we try to uh, increase the resources of the server, that we are trying to increase the RAM of the server or the storage of the server or other hardware to increase the performance of the our application. But there is one limit that up to which we can increase the RAM or the storage of the single server. Beyond that it is not possible to the increase the RAM or storage or any other hardware. So it comes to the limitation. But in case of the NoSQL, that we are not using the vertical scale, we are using the horizontal scale. Now what is the vertical scale and the horizontal scale? Okay, so as you can see that on the left side, that is the vertical scale, it is also known as the scale up, and on the right side, that the horizontal scale, that is also known as a scale up. So let's consider what is the vertical scale. In the vertical scale, that is in the vertical scale, that means scale up, we are simply increasing the resources or the configuration of that server, that is increasing the RAM or the storage. Okay, and in the horizontal scale, instead of the increasing the RAM and the resources of the single server, we are increasing the machines itself. So we are distributing the data on the different machines, so we can increase the machines as many as we want. There is no limit to increase, but for the vertical scale there is a one physical limit up to which we can increase the RAM or the storage of that server. Also for the vertical scale, it is easy to manage the single server. In the case of the horizontal scale, it is difficult to manage the different servers. But for the vertical scale, if this server goes down, then your whole application goes down. But for the horizontal scale, if this server or the distribution machine goes down, then other is up, so it will not affect that much to the your application. So it in the vertical scale also you can face the downtime when we are upgrading the resources. But for the horizontal scale there is no downtime. When we are you are increasing the machines, you are simply adding the machines and uh, moving the code to able to run on that machines also. So that's it for the vertical scale and the horizontal scale. For the relational database or the SQL, we are using the vertical scale, and for the NoSQL we are using the horizontal scale. So why not we can to use the horizontal scale for the SQL, so we can achieve the speed and the all the other features like the NoSQL. So basically in the SQL we are getting the data from the different tables. So to join the different tables we have to make sure that the tables are on the same server, so it will be easy to get the data and increase the performance using the join. We can use joins, but if the both tables are the different, it is much difficult to join the these tables. Also the our SQL or relational database follows some properties called ACID. So in that, and also the transaction, so it will be difficult for the all these concept to execute on the distributed system, that is on the horizontal scale. So in the transaction we have to follow the rules that it should complete all the process or should not complete the, if any step fails, then we should come back to the previous state. So it is difficult for the horizontal scale. For the distributed system, we can achieve that into the only in the single server, that is in the vertical scale. So that is why it is difficult to use the horizontal scale in the SQL. Okay, so now we'll consider the why the NoSQL come into the picture. Okay, so we understand what is the scaling, what is vertical scale or horizontal scale, what are the drawbacks that are with the SQL, why we are not able to use the horizontal scale on the SQL, how it is reducing our the performance. So in the today world, you know that everyone trying to implement the agile development model. In the agile development, in the sprint, yeah, we have to develop the code according to the requirement of the client, but in the each sprint the requirement should or could change, and this depend upon the client. If we are using the SQL, then it is difficult to change the all the schema structure or the mapping between the two entities, two tables. So if the requirement changes, then it is difficult to change a whole the schema. But in case of the NoSQL, it is not that much difficult as compared to the SQL becomes more complex when we are trying to change the database or the data structure on regularly. But in the NoSQL we can simply add many field. It depends upon the how it depends, or the it can be best suitable for the dynamic data, as we can achieve the fast development using the NoSQL. No need to worry about the linking and the schema designing, because it is the flexible for the schema. So that's it for the today's video about the what is the NoSQL. So also there is a one concept like what is the full form of the NoSQL. So many people thinks like it is the not SQL, but it is meaning like not only SQL, means it contain the feature of the SQL, also some advanced feature that is not present in the SQL. So that's it for the today's video. Stay up, stay connected with us by subscribing the YouTube channel. So in the upcoming videos we will learn about the how to install the MongoDB in our Windows and the Ubuntu, and after that we will simply start all the operations and the query of the MongoDB. So thanks guys for watching my YouTube video. We will see you again in the next video. Thank you.